Let's practice graphing a sine function together. For this particular function, we have f of x is equal to 6 times sine of the quantity of 1/3 x plus pi over 2 minus 6. Over here we have our formula for how we typically like to go ahead and look at these functions. So I'm going to go ahead and just rewrite our function here so it's in the same form. Our a value is going to be 6, that can stay the same. It's going to be multiplied by sine of, now if we're going to go ahead and figure out what b is, we basically just have to factor out the coefficient. That's going to be this 1/3 over here. So let's go ahead and factor out 1/3 in front. Let's go ahead and multiply that by x. So 1/3 times x, you can see here, that's going to be 1/3 x. But then what is going to happen over here with this plus pi over 2? Well, we factored out 1/3, so we have to go ahead and say that this is going to be minus, this is going to be negative, and if we're factoring out 1/3, we have to multiply this by 3. So we're going to say this is going to be 3 pi over 2. Now in terms of the minus minus, essentially the formula here has this minus h value, right? But because we have a plus here, hopefully it makes sense if we take away a negative, that's the same thing as a positive. And so if we go ahead and distribute here 1/3 times x, we see that 1/3 x, and then this would be essentially what? X plus 3 pi over 2. But if you go ahead and distribute 1/3 to that, these 3's would cross cancel and you end up with pi over 2, which is what we had over here, all right? Finally, we have this plus k. In this case, the plus k is going to be plus a negative 6. So that's how we know what k is going to be there. It's a negative 6. All right, so our a value here is going to be 6. Our b value here is going to be 1/3. The value of h is going to be negative 3 pi over 2. And finally, k is equal to negative 6. Now that we've identified our a, our b, our h, and our k values, we can go ahead and figure out a lot more about this sine function graph. Now because a is a positive value here, we're not going to have a vertical reflection. I'm just going to say there's not going to be one here. And now in terms of a horizontal reflection, our b value is positive here, so we're also not going to have a horizontal reflection, so we don't have to worry about those. Now for the amplitude, that's going to be the absolute value of a. Notice how a is positive 6, so the absolute value of positive 6 is just going to stay as positive 6. Next, for our period, our formula is 2 pi divided by b. Now our b is 1/3 here, so we can go ahead and figure this out and say this is going to be 2 pi divided by b. b is 1/3. Now if you divide by a fraction, keep in mind that we're just going to take this 2 pi, or 2 pi over 1, and multiply by the reciprocal of 1/3, which is going to be 3 over 1. And this is going to turn out to be 6 pi. So this would be the period of this function. So it looks like it's going to be a little longer than normal. Next, for our midline, we know the midline is going to be the k value, and the midline is also always going to be a horizontal line for a sine function, so it's going to be y is equal to whatever the k value is. Now k is negative 6, so that's going to be our midline. Now what's our minimum value going to be for this function? Well, it's going to be our midline take away the amplitude, so our midline is going to be at negative 6. If you go ahead and take away 6, then the minimum would be at negative 12. So it's going to be y is equal to negative 12. That's the lowest this function will go to. Now for the maximum, that's going to be going from the midline and adding the amplitude. So if we're at negative 6 and then we add 6, we know that our maximum y value for this function is going to be y is equal to 0. Now before we graph this particular function, let's remember what the sine parent function looks like. It's going to always start at the midline, at the origin, go up, then come back down, and then come back up to the midline. So this is what the parent function looks like. But if we go ahead and apply all the transformations we see in this particular function, let's go ahead and just kind of map out what's going to be happening here. So first, this negative 6 for k just means that we're shifting this whole thing down 6 units. The next thing is really the period is 6 pi, so it's going to be 3 times longer in the horizontal direction. So maybe it looks something more like this. All right. The amplitude is this positive 6, so that just means it's going to be going higher and lower than the midline, 6 times higher and lower than normal of an amplitude of 1. And the other thing to kind of notice here is that we're going to go ahead and make sure that we're shifting this whole thing, this 3 pi over 2 units to the left here. So maybe it looks something like this. So that's kind of the story we're going to kind of tell here. So let's go ahead and put all these pieces together. Now, out of all the different types of transformations here, I think that the horizontal shift can sometimes be the most confusing. And so while we do have a horizontal shift of this 3 pi over 2 units to the left, another way you can think about this is by taking that horizontal shift and dividing it by the period. This is going to let us know how much of that period we're going to be moving in which direction. So if our horizontal shift we know is going to be this negative 3 pi over 2, and we also know that the period here is going to be 6 pi, we're basically saying, well, what fraction of that entire period is that going to be? Now, if you go ahead and just simplify this a little bit, it's going to be negative 3 pi over 2. If you divide by 6 pi, we're going to multiply by 1 over 6 pi. So if you go ahead and simplify this, this is going to be negative 1/4. And so what this negative 1/4 tells us is that we're going to be shifting left 1/4 of a period. So the negative means that we're moving to the left. If it was positive, we would move to the right. And this value of 1/4 is really just a ratio of the period. Now, a full period we said was going to be 6 pi. So a quarter of that is going to be actually this 3 pi over 2, or 1.5 pi, right? 1.5 fits into 6 4 times. So whatever a full period is, which is 6 pi, we're basically going to move that whole thing 1/4 of that to the left. So hopefully that makes sense in another way of explaining how that's going to work. So our sine function typically starts at the origin, but we're actually going to be starting negative 3 pi over 2 to the left, since we just said we were going to be moving that much to the left. So it's going to be negative 3 pi over 2. And where are we going to be ending? Well, if we're starting here, we got to figure out where we're ending. Now, ending, we said it was going to be a total of 6 pi for a period. So where is going to be 6 pi to the right of that? I believe that's going to be positive 4.5 pi. But 4.5 pi is the same thing as 9 pi over 2, right? 9 over 2 is 4.5. So the distance between here and here is going to be 6 pi. So where's halfway going to be? Well, halfway going to be, if this is from here to here is 6 pi, that means that from the start to the halfway should be adding 3 pi. Now, if you go to add 3 pi onto this negative 3 pi over 2, that's going to bring us to positive 3 over 2 pi. So I'm going to go ahead and write positive 3 pi over 2. Okay, it's exactly in the middle between the start and the end. And then what about the quarter way? Well, between here and here, it's a total of 3 pi, right? So half of that is going to be 1.5 pi. So if you add 1.5 pi to here, or you take away 1.5 pi from here, we're actually going to end up at 0 over here. And if this is 1.5 and this is 4.5, what's halfway between 1.5 and 4.5? Well, it's a distance of 3. And so half of 3 is going to be 1.5. So if you go right in the middle, I believe that is going to be 3 pi. All right, so again, notice that from here to here, we have a total distance of 6 pi. Right over here, our total distance is going to be 3 pi. So here's 3 pi, here's 3 pi. And so this is basically going to say from here to here is 1.5, 1.5, 1.5, and 1.5. That's the whole idea of taking the entire 6 pi and then splitting it into those 4 pieces. So essentially, we're just taking the entire period and splitting it into quarters, or 4 equal-sized pieces. All right, let's go ahead and see if we can start putting this together now. So here is our x-axis. Now we're going to need a little more space for our y-axis here. Maybe something like this. Now our starting x location is going to be negative 3 pi over 2. So let's go ahead and put that in as our start value. And hopefully it makes sense. We're going to jump by 1.5 pi. So let's go ahead and set that up. So we can set up maybe something that looks like this. And this right here would represent our 1 full period. Now, what about our y-axis? We knew our minimum is going to be negative 12, so I went by 2's here. So that's going to be negative 12. Let's go ahead and fill in the rest of these. Then it's helpful to go ahead and sketch our midline, just because that's going to be where everything's going to be centered around. Then we really just want to think about how our sine functions are going to work. Our sine functions are going to start at the midline every single time. And then from there, what do? Well, they start at the midline, and they're also going to be ending at the midline. So we know that at the beginning of the period and the end of the period, we should be right on that midline. We can also look at our parent function and see that as well. If you also look at the parent function, you notice that halfway through, it's also going to hit the midline. So maybe it's important or helpful to go ahead and put these 3 points down. If we had some sort of vertical reflection of some sort, we would maybe go down then up, but there wasn't any vertical reflection at all. So we're just going to go up to the maximum. That's going to be a quarter way through. And then at 3/4 of the way through, we should hit the minimum. So we have our maximum at 0, and we have our minimum at negative 12. And then you can go ahead and just try and draw a smooth curve through these points, and it should look something like this. This would be 1 period of this function. Hopefully you found this video helpful. If you did, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.